photo is an example of a human-caused or human-helped situation. And so the erosion will be exacerbated by what's taken place on this property. This is a pretty dramatic example from the Kenai. So why do you guys think that bank erosion took place in this situation?
There's no vegetation. The vegetation is getting destroyed right around the house.
Right, so all of this took place actually within 1 year. You can see that the cabin was pretty close to the river to begin with, and that particular individual removed some of that vegetation to have a nice view of the river. I think it's really noteworthy to look at these trees back here and here. You can see where the bank was well vegetated. Those trees actually haven't moved, but the stream bank upstream of it sure did, because that vegetation was removed. So, one reason why bank erosion can occur, removing that vegetation.
So when somebody owns a piece of property like that, there's no requirements that they not do that? Is there, nobody's telling them not to build your cabin that close and destroy all that?
There are now. Yep. That hasn't always been the case, but there are requirements now. But you're correct. There are some requirements now for not only where developments are placed, but also what type of landscaping takes place along streams. This is another pretty dramatic example of ATV, UTV, and actually monster truck use, but this is from the Matsu, and you can show how it's got pretty negative effects to this little anadromous stream.
What stream?
I'm not familiar with exactly.
There's a stream in that picture?
Probably Jim Creek.
Looks like a mud puddle.
This thing's Jim Creek.
Yeah.
So this situation, greater rates of erosion, greater sediment into the stream, loss of spawning areas, smothering of eggs, quite a few bad things happen. I like Luke's picture of this a little bit more than mine because it shows what's happening along a greater stretch of the river here, but this particular situation, that riparian vegetation was removed, and really what happens here is the velocity speeds up along that hardened surface, and while you may have a temporary band-aid on your problem, you've created a bigger problem downstream. You can see the tip of the root wads that were installed downstream of this, and Luke's picture showed even more of that length of root wads, but velocities speeding up along this hardened surface created erosional situations downstream of it. So you may have solved your problem, but you probably made your neighbor angry.
So there's I think a good example of that you could, like in Homer, is that they keep putting riprap down the Homer spit on the west side of the spit, and the water comes in, and now it's channeling it all the way down to like the first boardwalk or whatever where the oyster co-op is, and now they're having serious erosion problems because that water's just hitting that break wall, and then it has to go somewhere, so it just funnels it out towards the end of the spit, and then it's, yeah, so that's exactly what probably happens in that situation in the river.
Well, and I think the river will see that, right?
Yeah.
It'll see
What
like
was that?
example.
But Picnicol, Gabion.
Oh, right, okay.
Oh, where they put the, what is
Right.
that old stuff from like
Yeah,
World War II,
so
that,
baskets, metal
metal baskets.
metal baskets with rocks inside.
Yeah.
So created
Created a back eddy.
yeah.
So I would say that at least 3/4 of the time when I'm meeting with a landowner, I get asked, why can't I just put concrete along my bank? And really the same, Luke described a lot of the good reasons why, and another reason why is it does primarily the same thing that sheet pile did. It speeds up water velocities and creates problems for your neighbors, and it's definitely not doing any good for salmon habitat along your stream bank. Landscaping is another cause of human-helped erosion. Clearing and mowing to the water's edge has a number of impacts. Like a turf lawn situation like this, one situation that occurs is when you have heavy precipitation events, you get surface runoff that's coming down and over your bank and can begin to create cuts such as this. I'm working with the landowner by Cooper Landing. I can pull up a photo here at the end of the talks here if we have time, but they're right on the lower end of Kenai Lake, and that overland flow situation, they're actually getting runoff from the highway and their big parking lot. It's created enough of a cut that they're within 6 feet of losing one of their guest cabins. So now this spring, we're in this really major project mode of having to put root wads in along their stream bank, regrading the stream bank, and then just really working hard to reestablish vegetation there. But it's all driven by the fact that they had landscaping in addition to parking lot, in addition to running water coming off the highway, that created a pretty major erosional situation.
Well, we all see that at Blackwater Bend where we cleared that grassy area, but you still have trees, it floods all the time now.
So the other thing that takes place is the landscaping changes the vegetational composition. So you're not having that taller vegetation along your stream bank, and that change also influences the root structure associated with the plants. So shorter vegetation has smaller root systems as opposed to tall, grassy, herbaceous plants and woody vegetation who have complex and extensive root systems that really do a great job of holding your soils in place. We have another Kenai example. This is pretty extreme, but just access to the river and trampling of vegetation causes erosion. And we'll see some much smaller scale examples of that today at the campground, and we'll actually all work together to fix a couple of those little situations where foot traffic is creating a bit of a problem on the stream bank. Have some fun pictures of historic methods to stabilize the shoreline. Like this one, it's some milk crates with rocks in it, stacked up to make a little wall. You can kind of see what's happened here, what the water velocities have done on the downstream side of this little wall. Tires, we don't see a lot of this. A lot of these have been addressed, but there's still one or two smaller examples of this on the Kenai. Avians, kind of like to think of these as like timed release capsules. you guys are witnessing this on Picnic Hole. Yeah, I mean initially they're speeding up velocities, and then over time they rust and fall apart, and then you have a different problem to deal with. Just a general throw everything you can over the stream bank and see what happens. Refrigerators and all kinds of fun stuff here. Didn't really work. Kind of just Detroit riprap. Still have a few examples of this, like the Cooper Landing project that I was just telling you about, where root wads are being installed. Pulling a few of these out of the stream bank from that particular property. And so I've talked a little bit about where it occurs, what occurs and where it occurs and why it occurs. And now I want to move into a few minutes talking about rehabilitation projects. And I kind of use the terms rehabilitation and bioengineering a little bit simultaneously. They're different, but when I say bioengineering, what I mean is an effort that takes place to rehabilitate a stream bank. There's about 4 goals, at least, I keep in mind when trying to work with someone to rehabilitate a stream bank. And the first one is we want to replace human-induced erosion by trying to simulate the natural bank and trying to restore vegetation to that site. So in an ideal case, we could move a site back toward more of a natural function and natural rates of erosion to restore salmon habitat. Well-established vegetation, overhanging vegetation, and undercut banks. The undercut bank here, when I'm meeting with folks, a lot of times people view this undercut bank as just like erosion waiting to happen. And in some situations it is, especially if you have the pitter-patter of feet on top of that stream bank regularly, it probably is a situation waiting to happen. But this type of condition with a well-vegetated bank and a healthy root structure is actually amazingly stable. And so it's actually a condition that we want to try to mimic, or we want to get back to at some point, because it's an important habitat element for salmon and other fish species and rivers. I also have folks feel that just the natural undulations of the stream bank are a concern. You know, it's kind of a human tendency to want to go to a property and have everything be stream. And that's not good for habitat, not good for the stream, not conducive to the salmon that we're trying to grow in our rivers. So the, you know, well-vegetated banks, the undercut bank condition, and the undulations here are what we strive for as we install rehabilitation projects and as we watch them develop and establish over time. The second goal or desire for rehabilitation projects is to install woody debris that provides shelter for salmon, substrate for macroinvertebrates, and you know, different and optimal water velocities for salmon, for juvenile salmon in particular. One of the first things that folks do when they buy a property on the river, especially if they're going to be using the property for fishing, is they take the woody debris out of the stream. And we don't want to get hung up on that. And again, we like everything nice and neat. We want a pretty straight stream bank. And that's kind of the first mistake that folks make. And so we try to recreate that as best as we can with bioengineering practices. You know, it's situations that warrant root wads. Root wads do a fairly decent job of getting some woody debris back into the river. And not to say that these are better than a natural situation, because they're not. In some sense, you could view root wads as hardening the stream, but they do address major erosion situations and do provide a little bit of salmon habitat at the same time. When the flow are up against these root wads, there's definitely areas for juvenile salmon to be in and of the root wads, and you know, fulfilling some of their little life stage activities. And the third desire is to get vegetation reestablished. Get that vegetation established to provide stability on the stream. Get that vegetation established to provide shade cover in the form of overhanging vegetation. That vegetation is providing terrestrial food sources, and it's also reducing excess sediments from entering into the river. This is the early stages of a rehabilitation project that show that bioengineering is striving to get that vegetation reestablished on the stream bank. Over time, that vegetation will establish, start to provide that overhanging vegetation, the woody vegetation, and also as that area really matures, would potentially provide like that woody debris input